Secondly, for quantum fluctuation to occur, there must already exist space and time parameters for it to fluctuate into. So you end up with a real chicken or egg problem here. Which came first? The parameters of space and time needed for a fluctuation, or the entire universe which is needed to set up the parameters for space and time to exist? And there's really only one real reply to this problem. The Heisenberg uncertainty principle requires that the universe always existed in some state, at least in a zero point of energy. However, consider the fact that physicists tell us that the universe is quantized and that nothing smaller than a Planck can even exist. A Planck, named after physicist Max Planck, is simply the theoretically smallest space in which anything with area or mass could exist. Now, an easy way to picture this is to look at a television screen. When you look at that screen, you know that that picture is made up of thousands of tiny little pixels. The smallest space that anything on the screen could exist would be only 1 pixel. You could think of the universe as being like an enormous TV screen, and the Plancks being the pixels on that screen. However, if the horizon of the universe were ever as small as just 4 Plancks, then a wavelength of only 1 Planck would be possible to fluctuate. That means that once you make the universe a 0 point of energy below a Planck's length, there's no longer any pixels of space within which for anything to exist. There's no space-time, which means no vacuum or anything to fluctuate into. With no fluctuations, there's no particle pair production, which means there are no virtual particles. This means that even if the universe always existed in a state of 0 point of energy, the theory just logically does not work. There's one final thing to consider about quantum fluctuations. The theory of what's happening in the Casimir effect is that these virtual photons are just fluctuating in and out of existence from nothing. However, a well-established law within the first law of thermodynamics, called the law of conservation of energy, states that energy in a closed system must be preserved. That means that within a closed system, like our universe, no new energy can be added or eliminated. It cannot be created or destroyed, it can only be converted. This means that within the quantum fluctuation observations, it's more likely that they're merely observing some sort of yet unexplained quantum conversion process, not the creation of completely new particles. Consider for a second another popular theory to the origins of the universe, the multiverse or bubble theory. Born from the need to explain how our universe became so fine-tuned to support life, the theory suggests that there is actually an infinite number of universes. The theory is that if there were an infinite number of universes, then an infinite number of conditions could exist. This gives them the ability to claim that our conditions are perfect because we just happen to be in the one universe where the conditions turned out to be perfect to support life. This is an interesting notion and it's fun to explore. I mean, it makes for great movies, but if this is the backdrop to your favorite sci-fi TV show, then I'm sorry to burst your bubble. Quite literally. This is because when you really think about it, the word universe means all that exists. So that means that even if something else did exist, it wouldn't be another universe because it still is included in the definition for all that exists. It would therefore be only part of our one universe. Say hypothetically that an infinite number of universes could exist in which all possible conditions existed. Then this would logically require at least one universe to exist in which its parameters were that no other universes exist. But now you have a real problem because that one universe would logically cancel out the existence of any other universe. You can see how the theory fails just from that logical standpoint. Also consider the fact that we know mathematically nothing finite can exist infinitely. Then there couldn't logically be an infinite number of finite universes. Some would then argue, well, perhaps the number of universes aren't infinite, but rather that there's up to as many as 1 billion with billions of different conditions. But this doesn't solve the problem, it only pushes it under the rug.
Imagine a grain of sand representing one universe. Now imagine all the sand in the Mojave Desert. And finally, imagine a billion Mojave deserts. That may sound like a lot of universes, and it is. However, it is still only a finite number. It's still only enough to fill a billion Mojave deserts, and then it would run out. Followed all the way back, we would still have to explain what started the first grain of sand, or universe. The theory only pushes back the inevitable problem of still needing an infinite source to get it all started. The theory has no more scientific basis to support it than the latest Steven Spielberg movie. It is pure science fiction. There's not one single observation that would lead us to conclude that there was anything beyond our known universe.